right, welcome back to Everything Mathematics and good day. Today we're going to continue our series on simultaneous equation, and our focus today will be how to solve a simultaneous equation when one of the equation is a linear equation and the other equation is a quadratic. Or by quadratic, we could see it as a non-linear. So if I might just do a quick illustration, so far the quadratic, all the simultaneous equation we have done, the two equation has been linear. In essence, we would have had, let's say, x plus 2y is equal to 3. And let's say we have something like x plus y is equal to 4. And by linear equation, again, for those of us that may not know, a linear equation is simply an equation in which when we draw the graph of it, we will get a straight line. And that's what we mean when we say linear. So if I go to draw this graph here, I will get a line. If I go to draw this graph here, I will also get a line. And the solution of this two linear equation, of course, will be the point of intersection. And that's what we do when we get a linear equation. So for example, if this is our Cartesian plane, this is our y and this is our x. This here will be the x value and this here will be the y value. So at this point, we will have an x and a y that will correspond to each other. Good? However, when we get an equation, so when you're dealing with two linears, we will get one, of course, solution, or one x, one y. But when we're dealing with a quadratic, for example, let me just write the general form of a quadratic equation. Ax squared plus bx plus c is equal to 0. When we're dealing with a quadratic, you will realize that we will be getting two values for x, and we will also get two values for y. And that could easily simply be explained in a drawing. The graph of a quadratic is represented by a parabola, or this curve here. And again, a linear equation is a line. So notice that the line can possibly cut the quadratic equation at 2 points. So this here is kind of forming like a secant. So of course, at this point here, we will have an x and a y. And at this point here, guess what? We will also have an x and a y. So when solving this, you realize that you will get two values for x. So x could be, let's just come up with some generic algebraic letter. X could be a and b, and likewise, y would now be c and d. Unlike when we solve two linear equations where we get one x and one y, when we're dealing with this, we more often than not, we get two values for y and two values for x. Of course, it is very possible that you could get only one value for x and y. For example, you could have this same quadratic equation here, but then your line so happens to just touch one part of the curve. So this here we have like a tangent. Good. And of course, if you have a tangent, there is only one x and one y. Let's just cut to the chase. Let me just explain this. So to solve, well, let's just solve it with an example. I think that's the easiest way to solve this for now. So supposing we have the equation y is equal to 2x squared plus 1. Notice this is a quadratic because we have an x squared. We could recognize the quadratics or polynomials with the squared term. It could be a cubic, it could be squared, it could be full power, all those denote quadratic. And y is equal to 7x plus 5. This is a linear. So we could call this equation 1, if we so please, and we could call this equation 2. Right. If you remember, when we did the regular linear equations, the aim was to line up our y's, line up our x's, and make sure that the coefficients are the same. Good. When we're dealing with a linear and a non-linear, the objective is quite different. In this case here, all we need to do now is find or substitute for either x and y, plug it into the other equation, and then solve whatever quadratic will arise. So this one is already ready-made for us. There's no shifting that we have to do here. So for instance here, notice that they told us y is equal to 7x plus 5. So all we do now, we take that fact and we plug it into this y up here, because y is 7x plus 5. So in essence, we're making a new equation. So we have 7x plus 5 is equal to 2x squared plus 1, because this here is y is equal to 2x squared plus 1, and y is also equal to 7x plus 7. So I just substitute that value. I substitute a given fact. And from here is just a matter of making a quadratic equation. So again, let's just do a little shifting around. I move the 7x and I will also move the 5x on the other side. And that will leave me with, and I'll move the equation on the left-hand side. So we have 7x squared minus 7x minus 5 plus 1 is equal to 0. And if I simplify that further, we have 2x squared minus 7x minus 4 is equal to 0. And with this here now, I will end up with a quadratic equation. And I simply solve the quadratic. Here I would use the AC method. So my AC here is equal to 8. And remember now, I need two factors of 8 that can add or subtract to give me B. And in this case, we could use minus 8 plus 1. So I'll have 2x squared minus 8x plus x minus 4 is equal to 0. Minus 8 plus 1 will give me back minus 7. And then I just do my grouping here. And here the common factor is 2x. We could see that. And 2x could go into this here x times, and 2x could go into that minus 4 times. And on the other side, the common factor is just positive 1. So that's x minus 4. That's equal to 0. And when I solve here now, you have your values or your roots of 2x plus 1. And then we have x minus 4 equal to 0. And we set each bracket equal to 0. And that will give us two distinct values of, first of all, x will be equal to, let me work it out. So here we will have 2x plus 1 is equal to 0, which is 2x is equal to negative 1, which is x is equal to negative 1/2. And on the other side, when x is equal to 4, x minus 4 is equal to 0, then x will be equal to 4. So notice we have two values of x, as I said earlier, and to these two values of x, of course, we will have the respective values for y. So again, just like typical old simultaneous equation, this is the point where we choose which equation we want to transfer to, and we find y. So let's see which equation is easier to work with. Let me use this equation, equation 1. I think this is a lot easier to work with. I think. Let's see how it goes. 2x squared plus 1. Good. So y is equal to 2x squared plus 1. And I want to find what is x. I want to find what is y when I put x as a half and x as over there. So when x is a half, so let's use the negative a half first, y will be equal to 2 into, and inside a bracket, I'm putting negative a half, hope you understand where that comes from, squared plus 1. If I solve this here, I will get negative a half squared, that's the same thing as a quarter, good, plus 1, which is equal to, let's see, that's a half, 2 times a quarter, that's a half, plus 1. 1 is the same thing as 2 over 2. And when you add these two fractions, you should end up with 3/2, which is equal to 1.5. Good? So that is what y is. So when x is equal to negative a half, the corresponding y value for that is 1.5. And that's what the work that we just did there. And of course, we now need to find the other value of y when x is equal to 4, of course. So again, if y is equal to 2x squared plus 1. Let's find out what is y when x is 4. So when x is 4, we have close bracket squared plus 1, and inside there we put in 4. X is 4, so we substitute that value there. And this will be equal now to 4 squared, that is 16. 16 times 2, that is 32. And 32 plus 1 is 33. Yeah, you have to be a little careful here. Some people might have probably multiplied the 2 by the 4 first. But remember, if you apply the laws of order of operation, the index always goes first. So you square first and then you multiply. If you multiply first and then square, you would have gotten 64. And then 64 times, you would have 2 times 4 is 8. 8 squared is 64, and 64 plus 1 is 65. So that would have been way too high. Well, not way too high, but it would not have been the correct answer. So here now, when x is equal to 4, y is equal to 33. So these are the 4 values that we found when we solve a simultaneous equation matched up with a quadratic equation, or non-linear, meaning that you wouldn't get a graph, you get a curve. So the essence is straightforward, but again, it comes with practice. You choose which one you want to plug into the other one. And as I said, this one is ready-made, so we had to do no alteration whatsoever. And once we figure that out, we put it into the other equation and we solve. And that should give us the answer. Let's see if I could find another example. Let's do another one. Let me just come down here. Right. I'm seeing this one might be a little too high-tech for our learners. Let's see if we could get another simple one. Oh, I like this one. This one is interesting. So here I'm seeing x plus y is equal to 14. And then after we have xy is equal to 45. This one might quicker fall under the realms of these guys. So let's call this one equation 1, if we please, and let's call this one equation 2, now that it matters. So the aim here again, remember, I'm finding either x or y, and then I'm plugging it into the other equation. But this one we have a little work to do. So here we have x plus y is equal to 14. I could find for x, if I want, I could find for y. Just now we find x first. So let us find y now. So to find y now, let us substitute the y. So x plus y equal to 14 is the same as x equal to 14 minus y. All I did, I moved this y on the other side here. Good? Transpose. So we got minus y, or you just subtract y from both sides. Good? So now I know that x is equal to this. And once I have this now, I could plug this x here. And then I find an equation and I solve. So I know that x is equal to 14 minus 1. So I'm substituting this x. So instead, I will have y multiplied by what I found x to be. X is 14 minus y. Good? And that's equal to 45. That's it there. And from here, it's just a game of algebra. Here, we just play around until we solve. So I distribute here, I distribute my y, and I will end up with 14y minus y squared is equal to 45. Yep. And then after, I go on the other side, I just shift around. I like my powers, the higher power to the highest, and then I go down. So this is the same as minus y squared plus 14y minus 45. I send this 45 on the other side, and all that's equal to 0. Good. And once I reach this scenario here, again, I find my AC, and I notice that my AC here would be 45. And again, I want 2 factors of 45 that can add or subtract to give me B, which is 14 here. And in this case, I think I could clearly see it's 9 and 4. Let's try that first. If it doesn't work, I would think to see if there's another factor. So we have minus y squared plus 9y plus 5y. 9 5s are 45, and 9 plus 5 is 14, minus 45. That's equal to 0. And I group now, there is common here, there is common here, 5 factors there, we have y as a factor here. So, common factor in the first one, I will have y, just y, there is nothing negative here that I could take out. Or should I put negative y? I could put negative y in over. Nah, let me leave it y, the one is not common. So here we will end up with negative y, yeah, negative y plus, what? 9. Yes, negative y plus 9. The y factor, the y and the 9 just comes up. Over here now, it wouldn't be positive, it would be negative 5 because we have a factor inside we want to take out. So here we want to end up with negative y plus 9. Yes, 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 yes. Good stuff. Right, and there, this at the end of the day will end up giving us two factors, y minus 5, and then we have minus y plus 9, yes, equal to 0. And of course, we're equating for both of them. And again, I hope we could see the long and short. I'm not teaching you how to factorize here. At this level, we have to know this. Well, at this point, we have to know this strategy. But of course, I have some videos upon factorization. You could always look at it. But here we could see that y will eventually be equal to 5. And y will also end up being equal to 9, positive 9. Yes, believe it or not, it will be positive 9. So these are the two values that we get for y. And now that we know that, we could find the values of x, and guess what? I want to use the second equation. I want to use this equation. It's just a matter of dividing. Good? So let's use this equation there to plug in the respective values that we just looked at. So xy is equal to 45. And we know what is y in both instances, right? So let's do one at a time. So when y is 5, we have x into 5. I forgot to change the color there. Anyway, is equal to 45. And of course, if we divide here by 5, we divide over here by 5. So when y is 5, x is actually 9. So when y is equal to 5, x will be equal to 9. And if you are sharp as me, you should see the opposite already. And when y, let me write it over again. So xy is equal to 45. But this time now we're proving for when y is 9. So when y is 9, we have this scenario here. And as a result, x will be equal to, well, it will be 49 over 9. And ultimately, x will be equal to 5. So when y, take that over, when y is equal to what? 9, x is equal to 5. So it's almost like the roles reverse. When you look at the two values there, it's like the roles reverse. But yes, that's basically how we solve it. So again, the essence is that you substitute for either x or y, you plug it into the other equation, and then you solve. Whatever you get, you solve for it, and then you put it back into the other equation to find the other missing value. So I trust that was clear enough. That will bring us to the end of today's video. So until the next time again, you take care and do enjoy.